In this session, we'll explore the fundamental internal architecture and memory organization of the MCS 51. So, our main objective will be to study the general architecture of MCS 51 and memory organization. The design of MCS 51 is structured based on the Harvard architecture, which separates program memory from data memory. To fetch all instructions from external memory, the EA, external access, pin needs to be grounded. Size of total program memory is equal to the size of internal and external memory together and can be a maximum of 64 kilobytes. When EA, external access, is linked to the supply voltage VCC, the initial instruction fetches occur from the internal program memory. However, if the instruction boundary is exceeded, the fetch will be conducted from the external program memory, as illustrated in the accompanying figure. The 8051 microcontrollers employ a pipelined architecture. This architecture permits the processor to fetch an instruction code while simultaneously handling the decoding and execution of its previous instructions. Similar to the Intel 8086 microprocessor, which can store 6 advanced bytes, the 8051 microcontrollers also utilizes this pipeline architecture. However, in the 8051 architecture, only 1 byte of the subsequent instructions code is fetched and stored in its pipeline. The pipeline architecture enhances processor speed. However, in cases where instructions are not in sequence, such as during program branching, the prefetched codes are discarded or abandoned. Now, let's explore the function of program lock bits. These bits serve to prevent unauthorized piracy. When these bits are locked or programmed, the contents of the internal program memory become inaccessible to external circuits. However, if external program memory is employed, these program lock bits cannot be utilized. A standard program memory erase operation would unlock these program lock bits, simultaneously erasing the entire content of the internal program memory. Like program memory, the maximum size of external data memory may be 64 kilobytes. 64 kilobytes of data memory limit is irrespective of the amount of internal, on-chip, data memory. Every iteration of the MCS 51 provides 128 bytes of internal data memory, while some variants like MCS 52 and MCS 54 extend this to 256 bytes of internal data memory. Regardless, all versions support a maximum external data memory of 64K. Consequently, the maximum data memory size for MCS 51 devices can be calculated as 64 kilobytes plus the size of the available internal data memory, either 128 or 256 bytes. Now, let's delve into the data memory structure of the MCS 51 and its segmentation. The internal data memory of the 8051 is divided into 3 distinct functional sections: the scratchpad area, starting from address 30 hex onwards, the bit addressable area ranges between the address 20 hex to 2F hex, and the register banks with address range starting from 00 hex to 1F hex. Lower part of the internal RAM accommodates 4 general-purpose register banks designated as bank number 0, number 1, number 2, and number 3. Each bank contains 8 general-purpose registers designated as R0, R1, R2, and so on up to R7. Multiple banks help in faster interrupt servicing. Out of 4 banks, only 1 can be active at a time. Initially, after system reset, bank number 0 is selected as default. This bank selection is possible through PSW, Program Status Word. These registers serve the purpose of storing data or operands during arithmetic or logical operations. Additionally, they can function as countdown counters. Register R0 and R1 within the active bank also serve as data pointers for indirect addressing. If not utilized as registers, they can alternatively serve as a general-purpose storage area. Next, 16 bytes after 4 register banks starting from address 20 hex to 2F hex contains 128 bits in total and are designated as bit addressable area. Each of 128 bits has an individual bit address varying from 00 hex to 7F hex. This area is expected to store bit variables for the application program. Bit addressable area is basically used to control motors or equipments requiring bit for control. If not used for bit variable storage, Then such unused bytes of this area may also be used to store information in the form of bytes. From 30 hex to the rest may be used for any general-purpose storage including the stack. After system reset, the stack pointer, SP, is initialized at 07 hex so that the stack may start from 08H onwards. Any unused bytes of the bit addressable area or unused register banks may also be used for general-purpose data storage. MCS 51 devices, highest address of scratchpad area is 7F hex. MCS 52 the highest address is FF hex as size of on-chip RAM is 256 bytes. Crystal is connected between pin number 18 and 19. The allowable maximum and minimum clock frequency varies from device to device. A general practice is to use an external crystal of 12 MHz frequency unless serial communications are necessary. For systems employing serial communication capabilities, a crystal operating at a frequency of 11.0592 MHz is deemed more suitable. This frequency facilitates the easy generation of standard baud rates such as 9600, 4800, etc. For CHMOS type device, this external clock signal must be supplied at XTAL1, pin 19, while XTAL2, pin 18, input must be left as shown in figure. For TTL type device, this external clock signal must be supplied at XTAL2, pin 18, while XTAL1, pin 19, input must be grounded. Multiple number of clock oscillations are used for various purposes. 2 pulses produce a state. 6 states generate a machine cycle. Instruction needs 1, 2, or 4 such machine cycles for fetching the opcode and its execution. ALE signal is available for each machine cycle. In a prior video session, we explored the power-on reset circuit. Now, let's delve deeper into the functioning of the power-on reset and endeavor to comprehend its circuitry. The reset or power-on reset function needs to remain active for a minimum of 2 machine cycles, equivalent to 24 oscillation periods. Throughout this duration, several internal registers undergo initialization. Notably, the program counter, PC, is cleared to ensure that the initial instruction fetched after the reset is sourced from address 0000H. For major thing happens when power-on reset circuit is activated. Program counter, PC, is cleared. Stack pointer, SP, is initialized by 07 hex. Register bank number 0 is selected. All ports output is set to high, that is FF hex. Upon supply voltage activation, it swiftly reaches the positive 5-volt level, resulting in a rapid increase with a high-frequency response. Consequently, the capacitor's reactance is minimal due to the high frequency. As the voltage stabilizes, it transforms into pure direct current, DC, and the capacitor gradually charges in line with the time constant illustrated in the figure. This charging process extends for a duration spanning at least 24 clock periods. Hence, the capacitor and resistor values are carefully selected to ensure that the charging period exceeds the 24 clock periods. When the system or microcontroller is switched on, the reset is called power-on reset or cold reset. If manual key is pressed, then it is called hot reset or warm start. The register values are compiled into a table following the operation of the power-on reset circuit. Thank you for joining us in this comprehensive session exploring the general internal architecture and memory organization of MCS 51. We hope this session has provided you with valuable insights into this technical realm. To stay updated with more engaging and informative technical videos, don't forget to subscribe to iNet Tech Talk on YouTube. Join our community to delve deeper into diverse technical topics, explore innovative concepts, and expand your knowledge base. Sharing knowledge fosters growth. Please share this video with your peers and friends who might find it beneficial. Subscribe now to iNet Tech Talk on YouTube and be part of our journey to explore exciting technical insights. Thank you for being part of our audience.